Hey everyone, in this video we'll be taking a look at Amazon's DynamoDB service. DynamoDB is a NoSQL database, and some people might say it's pronounced SQL. I personally prefer SQL because it is an acronym. SQL stands for Standard Query Language, and essentially what a query is a command that you would run against a database to access and manipulate data. Anyways, for those of you who don't know the difference between a non-relational database and a relational database, that's what the no in NoSQL means. I will clarify that quickly. So in relational databases, your data is going to be tabular. That means that you define a schema, and then all the data must match that schema. So in this example, we have a list of users, and every user must have an ID, a name, an age, and a city. If we were to try and add another attribute, like income, for those users where we don't know their income, we would actually have to put a value here. That value would be null because we don't know it. But you can see how all the items or elements or entries in this database have all the same attributes. Another aspect to relational databases is how you relate data. So for example, suppose that we had a table of comments, and we wanted to map these comments to the different users. In order to do that, we would have to use what's called a join table. And all a join table does is it maps the list of comment IDs here with the list of users. A non-relational database is a lot less structured, and so this would be an example of an entry for a non-relational database. So rather than having to use a join table to link the comments to our user Michelle, we could just add it to the property of our object here, which is using JSON notation. So going back to our command line here, we're going to get started. So to create a table within our DynamoDB database, we will use AWS DynamoDB create table, and then in this example we will be using a table of cats, and so we will call it cats. And then every cat will have an age, and the type will be a n for number, and every cat will also have a name. Here we're using cat name because name is a reserved keyword in DynamoDB, and if you were to try that, it would complain. Just be aware of that. And then the type will be S for string. And then we're going to define the key schema. So for DynamoDB, you have two kinds of keys. You have a partition key and a sort key. And the way DynamoDB works is the tables within our database are broken up into partitions. And the partitions are determined by our partition key. And within these partitions, the items are sorted by the sort key. And so what DynamoDB will do is it will use a hash algorithm using these keys to figure out where the item is. So the attribute age will use a key type of hash. Hash in this example, or in AWS I should say, refers to partitions. And so we are partitioning based off the age. And then for cat name, we will use a key type of range, range being the sort key. And then lastly, we're going to specify the provisioned throughput. And the best explanation for provisioned throughput is that basically you have capacity units so read capacity units and write capacity units, and you will want to multiply these units by 4 kilobytes. And so if you had 100 read capacity units, you would be able to read data at a rate of 409,600 bytes. And the example they're giving here is if, I don't know if you guys can really see that. The example they're giving here is that if you wanted to read a table that contained 20 gigabytes, if you only had a read capacity of 100, well, it would take 14.56 hours in order to retrieve all that data. And so whenever you define your DynamoDB table, you want to make sure that you give it enough read and write capacity. Otherwise, it will take a lot longer than it needs to. And so for our example, we will just specify 5 because we won't have a very large table. And we'll do the same thing for write. I misspelled it. Provisioned. I must have misspelled something else. Range has to be all capital, that's why. All right, there we go. And for every database, you can have multiple tables. You can list the tables by using DynamoDB list tables. And you can see our cats table is the only one we have in this database. If we wanted to put a cat into our database, we would use AWS. Actually, wait, hold on. We'll want to create the file first. And so our first cat will have a name of Mimi. The S here is specifying that it's a string. And then the age, we will use an N to specify that it's a number, and Mimi will be 5 years old. All right, so now if we go back here and do AWS DynamoDB put item table name, which is cats, and then we're going to pass in our cat using the file like so. And then to view all the items within our table, we can use the scan command. And so AWS DynamoDB scan table name, which is cats. And you can see right here that we have our cat Mimi. If we wanted to add a couple of more cats, we could change this to Joe. Say Joe is 1 year old. Run that command again. And then we can change this to maybe Bob. Bob will be 2 years old. Run the command again. So if we ran scan, you could see that we have 3 cats. Now you can be more specific. If let's say you had a massive database with thousands and thousands of entries, you wouldn't just want to use scan all the time because that might take a while to return the value. Sometimes you'll just want a specific cat or entry, and you can do that using the query command. But before, we will create a file called expression attributes. And here we will use name and then string, and we're going to query for our cat Mimi. And then the age will be 5. Alright, so to query with the AWS CLI, you're going to want to do AWS DynamoDB query, again with the table name, which is cats. The key condition expression is where we map our attributes to the variables right here. And so cat name is going to be name, and then age is going to be age, like so. The expression attribute values is going to be what we defined in our file. And you can see right here, it only returned Mimi and not all the other cats. If we wanted to delete a cat or remove an entry, we could use AWS DynamoDB delete item. The table name will be cats, and then we will use what we have in our cat.json file, so we'll remove Bob. And so the key will pass in our cat.json. If I run scan again, you can see that Bob is now gone. If we wanted to delete the entire table with all of its entries, we could run AWS DynamoDB delete table name cats. If I ran AWS DynamoDB list tables now, you can see that we don't have any more tables. So thank you for watching. If you have any questions, let me know in the comments. Ciao.